Good morning, everyone. Nice to meet you here. First edition of CodeCamp Timisoara. Big kudos to the sponsors who made this possible, to the partners, to the communities, and to the speakers who are here. I'm Vlad. I mostly go by Rain on Twitter. I'm a consultant. I work as a JavaScript instructor, and I'm also a Google developer expert on web technologies. And I'm no Morgan Freeman, so you'll have to deal with whatever I'm saying. And I look better in the photo than I do in reality. So we're going to talk about React Fibre. Let's see, quick show of hands first. Who's using React? Okay. Who's heard of Fibre? All right, so pretty much all the people that are using React have heard of Fibre. So let's see, well, what is React Fibre? Give me an idea.
The new version of React.
The new?
The new version of React.
The new version of React, but it's actually a little bit more than that.
It's an improvement in performance in React.
All right. I'm hearing some.
The algorithm for performance.
I'm hearing some very good ideas here. Let's take a step back and imagine React, or think about React as mostly being formed out of two major parts. So there's the reconciliation algorithm, which is basically the algorithm that does the difference behind the scenes and outputs the computed difference that needs to be applied to the UI. And there's the rendering part, which takes those differences and actually applies it to the HTML. These are two separate things in React. Reconciliation and rendering. The fact that they're two separate things also allows React to have custom rendering for other engines, like React Native, for example, who targets the native platforms. Fibre is a re-implementation of the entire reconciliation algorithm. It's rewritten from the ground up. So everything that is about React doing the diffing behind the scenes, the virtual DOM comparisons, and so on and so forth, has been completely rewritten. And it's called Fibre. One very interesting thing, and a very big change that Fibre actually brings, is in the old implementation, the reconciliation algorithm was something that was happening and it wasn't possible to interrupt it. Fibre's reconciliation algorithm is interruptible, which means that you can do chunks of work and then come back to them in an asynchronous rendering fashion and diffing. This is from where the big performance improvement actually comes. So we're going to explore together some of the things that are new in React Fibre. There's this idea of perceived performance improvements. There are error boundaries, support for custom DOM elements. Who here has been annoyed by the fact that in React, every single time you want to return something, you need to wrap it in a wrapper component or a div or something like that? Right? You couldn't have multiple return children. Okay, that's fixed now in React 16. You can actually return multiple children from render. And there are some other improvements as well, like, for example, the total size of the library has been taken down a bit. I think now minimized and gzipped, it weighs in roughly around 39 kilobytes, which is 5 or 6 kilobytes less than the previous version. Okay, perceived performance improvements. And I want to stress a little bit the word perceived here. The idea that this word actually exists is the total work that React Fibre does behind the scenes is the same. When you need to render your UI and basically apply some updates and have your application change, the total work is the same. What React Fibre does is it can break that work into asynchronous things and it can render them incrementally, but the total work is the same. That's why we say it's a perceived performance improvement, because the chunk of work that needs to be done hasn't changed. It's just done differently in bits and pieces, not all at once. So let's have a look at how the old reconciler worked in order to understand a little bit this algorithm. So this is a work queue, and when I say work queue, it's just an imagined thing of updates that need to happen to your application. For example, I don't know, a big component, including its children and some other children components, having to re-render. And here's the main UI thread in the browser, with these little boxes being roughly the equivalent of each frame, which weighs in at about 60 milliseconds. So you can get that 60 frame per second nice look and feel in your application. So what happens is, let's say that there's some work coming in, like a big component that needs to update itself. That component has a render method that gets called behind the scenes, and that triggers subsequent calls to render methods for every children of that particular render method. All of that thing happens at once. It's a function that calls another render function, that maybe calls another render function, and so on and so forth. They all get put on the call stack in the browser, and they execute until the call stack is empty. That work is something that you cannot interrupt. And when it goes into the browser UI thread, and when the JavaScript deals with that, it may actually take more than a frame. All of that computing, all of that JavaScript that is being done over there can actually take more than 60 milliseconds, which causes the frames to drop and your application to look a little bit laggy. So if you have multiple works coming in, multiple components need to update, multiple stuff that we need to do, basically you can see how those add up, and slowly our frame rate starts to drop. This is a little bit of text. I know, it's true. It's also an excerpt from React's design principles. So this is something that the guys in the React team wrote before React Fibre came in. And they said, okay, in its current implementation, so prior Fibre, React walks the tree recursively and calls every render function, and basically the whole tree gets updated and so on and so forth. They also said, we can prioritize work coming from a user interaction over less important background work. That was one of their ideas. It wasn't happening in React 15 or earlier. But they thought of it. They knew that this particular approach of React's reconciliation algorithm is not necessarily the best way to go forward. So actually in UIs, applying a certain update immediately after it comes immediately after it comes into the work queue is not a very good idea. In fact, doing so can often be harmful and can degrade the frames per second, as we've seen, and also alter the entire user experience. So it's not necessarily the best path. And also, not every type of update that you need to do is equivalent. Maybe, for example, something is a little bit more important for the user than something else. Example, if you're seeing an animation on the screen made via React, you want to see that fluidly happening. That's something very important that can actually override, or should override, in React's team opinion, an update coming from the store. So the work is not necessarily equivalent. There are two basic approaches that we can take in general from an architectural perspective to handle that work asynchronously. There's a push and a pull-based approach. The push-based approach means that React as a library, for example, would give you, the developer, the control to say, I want this work to be handled first, I want this update to come in second, I want this one to come in third. So you would be in control of how to schedule and prioritize that. There are frameworks who do that, but not React. React has a pull-based approach, which means the library decides for you, which, in all honesty, sometimes is way better. So, what's different about React Fibre? So as I said, it's completely backwards compatible, so it's a rewrite, but it's completely backwards compatible in terms of API. There are some new things that have also been added, but honestly, and we have examples. I was talking with Alex this morning. He had a project where he upgraded from 15 to 16, seamless upgrade. That's it, npm install, and all good. So it has this idea, it promotes this idea where chunks of work are being split into different pieces, and you start to promote this incremental rendering. You split your work, and you no longer do all the reconciliation subsequently at the same time. It has the ability, because of that, to pause work, to resume work, to continue, or to abort altogether, and even reuse bits and pieces from previous calculations during the reconciliation algorithm. This is what gives you that performance improvement all in all. And in order to do that, they had to completely rewrite everything, and they did so by introducing the new concept. And this is what's at the base of React Fibre, and from where the entire new algorithm also gets its name. It's a new entity, a new data structure, and it's called a fiber. And we're going to talk about what is a fiber. So, as I said in the prior versions, when there's a render function happening, that particular render function can call render functions for other children, components, and so on and so forth if they are. So behind the scenes, there's just a JavaScript function. It gets put onto the call stack in the browser, and then that function calls another render function. That gets added to the call stack. That function may call another render function. That gets added to the call stack. And then once the entire tree has been recursively traversed, then functions get to be executed and popped out of the call stack. The call stack works until it's empty. There's no way to pause the call stack or control it in the JavaScript environment. So what they did with Fibre was that they took the whole idea of a call stack from the browser and they re-implemented it in JavaScript by creating a virtual call stack. And that virtual call stack is made out of small frames, the same way you would put a function on an actual call stack, the same way you can put a virtual frame, which is actually a fiber, on this virtual call stack. It's the same idea with the virtual DOM behind the scenes, right? They also took the DOM and re-implemented the entire structure in JavaScript so that the library doesn't work with the actual DOM. So a fiber is basically a virtual stack frame behind the scenes. And it has the ability to call some APIs like request idle callback or request animation frames, which are things that are present in all modern browsers, and to take advantage of those in order to schedule chunks of work behind the scenes. So the fact that you have now a virtual stack frame that you control, and you no longer rely on the browser stack frame as the main work executing context, allows you to take that frame and do whatever you want with it, including splitting it into different chunks and controlling it differently. It allows you to have very fine-grained control over it, which in the end allows this allows Fibre to have this asynchronous rendering property, which is awesome. Behind the scenes, a Fibre is nothing else than a JavaScript object. And it contains a lot of properties, but these are some of the most important ones. And we're going to explain them one by one. So type and key, right? The type of a Fibre describes the component that it actually corresponds to. So it can either be a custom component that you wrote, like, I don't know, my component or header or footer or whatever, but it can also be like an HTML tag behind the scenes, like a div or a span or something. Who's using keys in React? over here. Keys. Right? They're very useful for performance. Keys allow you to allow the reconciliation algorithm to keep track of certain elements being created and to optimize for the best rendering algorithm that there is in order in such a way that I can actually reuse part of the elements if they have been defined with a key that never changes during the difference. So I definitely recommend you using keys, even if it's not React Fibre. But in Fibre, keys have the same idea behind the scenes. They're used to keep track of already created elements. They're very good for performance. Okay, child and sibling. In all honesty, in the old algorithm, only child existed, and it wasn't within a fiber. But now there's also the sibling property. These fields point basically to other fibers. And the fact that there is a child as well as a sibling now makes the whole returning of multiple components possible. The return property is basically the fiber to which the program should return after it differenced or diffed certain components. And you can think of it basically as a continuation or a recursive breakpoint within the entire asynchronous rendering pipeline. Remember, I told you that Fibre is capable of reusing previous computed work. And the way it does that is because there's a pending props and a memoized props thing that lives in this Fibre object. Those are actually just simple arguments to the functions behind the scenes that React Fibre uses. And those arguments are being, pending props, they're being calculated and cached when the function first executes, and memoized props when it ends. So if at a certain point you want to re-execute the function again, and the arguments or some of the calculation hasn't changed, you're able to reuse that without applying the algorithm anymore. You just used some old cached versions of the same computations. This gives you an extra speed increase. Pending work priority. This is actually a number behind the scenes, nothing too fancy. It goes from 0 to 5. And this says basically how important is the work that needs to be done. 0 means there's no work happening. And from 1 to 5, the work is decreasing in importance. So number 1 is the most important, and 5 is not something that the algorithm cares too much about. It doesn't mean it's not going to do it. It just means it will delay it a little bit. 1 is reserved for synchronous work. Something like, for example, when you're typing in an input, you want to see the state being updated as soon as possible. You want to get instant feedback. You don't want to have delays while you're typing. 5, for example, is reserved for off-screen work. Maybe your entire application actually has just updated a certain component, and that component has some children components which are not visible on the screen at this point. React knows that, and if something is not visible, it's not going to assign very big priority to those particular components in updating, because the user will never see them, or at least will not see them in the first place anyway. So React is pretty smart to also know how to prioritize work based on the actual viewport of the user. And output is something that's created only at the leaf nodes, basically, and it always goes down to HTML tags, and that output is combined recursively fiber by fiber. So let's see a little bit how this is different than the old reconciliation algorithm. So in Fibre, we have this particular chunk of work that has come in, and basically what the algorithm does is it takes one chunk of it, one fiber, and it says, okay, I'm going to do this. I'm going to put it on the UI thread. I'm going to see if I can do it. Okay, everything is good. And then the algorithm comes back and asks, do I still have work left to do from this particular thing? And do I still have time? And the answer is yes, there is still work to be done. So we can take another chunk and put it on the same frame stack, on the same frame in the actual browser, because we're still below that 16 milliseconds limit. I have the ability to basically break that into multiple chunks of work. I take the next chunk, the next frame, the next fiber, I put it, I execute that, I render that as well, and then, hey, do I still have work to do? And do I still have time? I still have work to do, but I don't really have any more space in this frame. So I'm going to take the last chunk of work and prioritize it for the next frame. Behind the scenes, this is done with request animation frame API. So this is how work gets split over multiple frames, and basically we make sure that doing something like this always keeps the frames under 16 milliseconds, which will give you that nice fluid experience. So coming back to this idea, so if I have some work coming in, and while I'm at the second, or during the execution of that particular chunk of work, there's a new update coming in. And that new update is actually even more important than what I'm doing at this point. Maybe what I'm doing at this point, I don't know, is some updating of the data store or some rendering of a component that I don't get to see, but then there's an animation being triggered or the user types something in an input. So that's an example of a chunk of work that becomes priority to what I was doing at that point. So if a new chunk of work comes in and it's more important, it gets in front of the work queue and it supersedes whatever it was done. The old work either gets discarded or gets cached and paused, and the new one gets to take the main stage. So I start looking into the new type of work that came in. I start splitting that into multiple frames. I start planning those frames, those fibers into frames in the browser. I start planning them, and once I have finished rendering everything that was in that priority chunk of work, I can go back to my old thing that I was doing and resume it. This can also be mixed, like this particular thing could be in the same frame with parts of the work that was being done from the more priority fiber. It depends on what exactly is the application doing and how important it is. So this is how the algorithm works in the new version. And to actually demonstrate this a little bit, I have a couple of demos. We're going to go through a demo of performance. I'm also going to show you some things about error boundaries, custom DOM elements, and yeah, then we're going to talk about whether or not we can use Fibre. So we're going to see a stack versus a Fibre implementation demo. The stack demo is basically prior React 16. It's called the stack because there was no notion of the virtual call stack at that point. So it's called the stack because it was relying on the actual call stack within the browsers. So let's see this particular example, which will render a triangle. Right? This triangle constantly expands and shrinks. This is an animation happening, and it's something very important to the user. As well, this, hopefully you can see there are some numbers that are being shown in these particular small circles. That number gets incremented from 1 to 10, and then it gets resetted, and so on and so forth. That's with the global set state that happens on all of those components. So you can see you don't really have much of a clear user experience and nice UI here. Things are lagging a little bit. The animation is not cursive. The update is also not cursive. so nothing gets shown that well for the user. And also, if you hover over a certain element, it makes it yellow, so this hovering is also kind of like delayed and everything. Let's see an example of a Fibre implementation for this. The animation, because it's the most important type of work for the user, and it needs to be fluid and cursive, is prioritized. And so it becomes important work, always gets access to the first frames, and thus it becomes something that the user can see very fluidly on the screen. The update that happens behind the scenes sometimes gets prioritized, sometimes it doesn't. And also the hovering over works a little bit much better. This is also instant feedback that needs to happen for the user. I haven't written this demo. This was actually the original demo that the team at Facebook decided to promote Fibre with. And if you want, you can come up after the talk, and I can give you the link or tell you where I found this. All right. So that's about it about performance. But there are some other things that are part of this new release in Fibre. And one of them is custom error boundaries. Error boundaries are simple React components that you can write and take advantage of a new lifecycle component that will actually allow you to catch all errors of the children component and that particular component as well. It's like a try-catch for your React components behind the scenes. At this point, if something fails in a React component in terms of a JavaScript error, a syntax error, reference error, or something like that, your entire application may actually break. Error boundaries allow you to take advantage of this new lifecycle hook, which is called component did catch. And this component did catch will actually trigger when something from this component or children component errored out and bubbled up to the surface. And to give you an example, these two counters here are inside the same error boundary. So if one crashes, then the boundary will replace both of them. And these are just okay, something like this?
Yeah.
Okay. So these two things are just counters that you can click on, and when you get to 5, it errors out intentionally. So if I'm on this one, I click and I error out, both of the components disappear. They were in the same parent that was doing the try-catch, the component did catch implementation, and these two counters are separate. So for example, if I get to 5 with one of them, the other one still stays. You can take advantage of component did catch and error boundaries in order to have parts of your application fail, but not the entire system. This is pretty cool. Okay, let's see. What else do we have? DOM changes demo. Let's look into this as well. There are some things that you can do right now. Custom attributes. You weren't able before, let me see if I can zoom this a little bit. You weren't able before to apply custom attributes to your components. Like saying something, my custom attribute equals I don't know what. This is because behind the scenes, React, old implementations, they were keeping a list with all the allowed attributes for elements. And if that particular thing that you wrote didn't match the list, there was no rendering. But now, if you look at this and you inspect it, you can basically see that we have my custom attribute being rendered here. Maybe I can zoom this in a little bit too. So it applies, it gets applied. And yeah, can you use this? Initially, when I made the presentation, React Fibre was still in release candidate, but the truth is that it was officially released. Let's see, I think, 26th of September. So it's, I don't know, 3 weeks or something old. which is like in its infancy and the ecosystem. It has since then worked perfectly. There has been no patch released for it or something like that. So you can actually use it now as a stable version in production. Okay, so let's see. This is a list of a couple of resources if you want. You can find me after the talk, and I can point you to some of these either talks or explanations of how the architecture works behind the scenes. Thank you very much for listening to me. I'd like you to take this advice to heart and always be smiling, especially when you're dealing with JavaScript. I know this can be hard sometimes, but keep on smiling and do that. And thank you. That was it.